Hi everyone, welcome to the video over domain restrictions. So we're going to talk about what can restrict the domains of our functions. So as a reminder, the domain is the set of all of our x values. So there are two types of problems that would affect our domain. Okay, so these are important to know. The first one would be the square roots of negative numbers. So this is going to be anytime you see the square root symbol or the radical. Okay, this would be any even roots, but we're going to focus on square roots in this video. Next, it would be anything that would cause us to divide by 0. Okay, we never want to divide by 0, so if we see that there's a fraction with some variables in the denominator, we'll have to figure out what would make us divide by 0. So, starting off, we have the square roots of negative numbers. Okay, it's important that you cannot take the square root of a negative number. Okay, to solve, you're going to set everything under the radical to be greater than or equal to 0, and then you just solve for x. So if we look at our first example right here, we have f of x equals the square root of x plus 4. So we're going to take what's under the radical, and all we're going to do is say that it's greater than or equal to 0. Once we have that, we go ahead and add, or we solve for x. So to do so, we are going to subtract 4 from both sides. And when you do that, we get the 4's zeroing out. And we're left with x is greater than or equal to negative 4. So this right here is our algebraic notation. Okay. We also need to understand the interval notation. So what this is telling us is that all of our x values are greater than or equal to negative 4, which means if we start at negative 4, it's going to be included, so we use a bracket, and they're always getting bigger than negative 4, so it's going to go into infinity, and that right there would be our interval notation. Either one of these is acceptable, but you will most likely see this interval notation right here. Okay, let's look at number 2. F of x equals the square root of 2x minus 1. So we're going to take what's under the radical, and we're going to say that it is greater than or equal to 0. So again, we're going to solve for x. So we start by adding 1 to both sides. When I do that, my 1's zero out. I'm left with 2x is greater than or equal to 1. Next, I am going to divide both sides by 2 to get x by itself. When we do that, we get x is greater than or equal to a 1/2. So again, this is our algebraic notation. If we're thinking about it, it's telling us that all of our x values are greater than or equal to 1/2. So since it has the or equal to, we use the bracket. We have 1/2, comma, and they're always getting bigger, so it goes to infinity. And again, this right here would be our interval notation. Okay, so that is it for the square roots of negative numbers. If you have any questions on this section, go ahead and write them down off to the side and be sure to ask your teacher the next time you see them. Next, we're going to talk about division by 0. So we never want to divide by 0, okay, because it gives us an undefined value, okay? So what we're going to do to solve these is you're going to set the denominator equal to 0, and then you solve. So if we look at our first example, g of x equals 3 divided by x minus 5. We're going to take this x minus 5. We're going to set it equal to 0. When we do that, it allows us to solve. So we add 5 to both sides. And when we solve, the 5's cancel out or 0 out, and we get x equals 5. So what this tells me is that when x is 5, we would be dividing by 0. So we want our domain to include every value but 5. So if we're starting from the left, we're going to start at negative infinity. Okay? And we go all the way until we get to 5, and then we have to stop. Now remember, it cannot be 5, so we're going to use parentheses because it is not included. Then we have to go on the other side of 5. Again, we get really close, so we're going to have 5 there. And it's going to go all the way until we get to infinity. Okay? Because I have two different intervals, we're going to conjoin them with the U in the middle that's just saying and. So the U is just representing and. So I have negative infinity to 5 and 5 to infinity. The reason there's parentheses on the 5 is because we do have an asymptote at 5. And so we get really close to it on the left side, and then we jump over it and get really close to it on the right side, and then we go on to infinity. So this would be our interval notation that represents the domain of g of x. Okay, looking at number 4, we have h of x equals 3x minus 5 divided by x squared minus 8x plus 12. So again, we want to know what is going to make us divide by 0. So we take this, we set it equal to 0. Since it is a quadratic function, we need to factor. So we ask ourselves, is there a greatest common factor? We look, there's nothing that all of them have in common, so there's not one. Then we can go to our x. Okay, we're going to put the 12 on top. We're going to put the negative 8 on bottom. So we have to think to ourselves, what can we multiply to get 12 and add to get negative 8? Well, if I'm going to add to get negative 8 and multiply to get 12, both of my signs need to be negative. So if you're unsure, you can list whatever numbers multiply to give you 12. So if I think about it, 1 and 12 get 12, but if I add them, I'm not going to get 8. Then if I think about it, I have 2 and 6. If I add 2 and 6, I can get 8. If I want a negative 8, they just both have to be negative. So now that we have that, we make sure that there's not a coefficient in front of the x squared. In this case, there's not. So we can go ahead and go factor to x minus 2 and x minus 6. Since we have two factors, we're going to apply the zero product principle. All that means is that I'm going to take each factor, so x minus 2, and set it equal to 0, and x minus 6, and set it equal to 0. Then we solve each individual one. So to solve this first one, I am going to add 2 to both sides. When I add 2 to both sides, the negative 2 and the positive 2 zero out, and I'm left with x equals 2. When I add 2 on my second equation, when I add 6 on my second equation to both sides, okay, my negative 6 and positive 6 zero out, so I get x equals 6. So now we have two zeros, or not two zeros, I'm sorry, we have two values that would make our denominator equal 0 and cause us to divide by 0. So what we're going to do is we're going to start from the left side and work our way to the right side, and once we get to one of our values that make our denominator equal 0, we're going to stop and then rewrite the interval. So if we're starting at the left, we're starting at negative infinity. As I keep going to the right, the first thing I stop at is a positive 2. Then I pick up on the other side of 2, and I go until I hit positive 6, because there's another value there that would make me divide by 0. And then I stop. And then I pick up on the other side of 6, and I keep going all the way until I get to infinity, and then I'm done. So this right here would represent the domain for number 4. Okay? Visually, if you kind of need to see it, what is happening is we have a graph right here, and we have a vertical asymptote right here at x equals 2. And I have a second vertical asymptote right here at x equals 6. So our function is doing something similar. It's not exactly this, but maybe we have something that goes like this, and then maybe something here, and then maybe something here. Okay, that's not exactly what's happening, but that's the kind of idea of what this domain represents. So let's go over it one more time. As I go along the x-axis, okay, I start at negative infinity, I go and I get to 2. Then I pick up on the other side of 2, and I go until I get to 6. Then I pick up on the other side of 6, and it takes me all the way to infinity. Okay, so that is how you do the domain when you're dividing by 0. So if you have any questions on this part, make sure you write them down and you ask your teacher the next time you see them. And that's it for this video, and I will see you in the next one.